called input capture, output compare. What you're doing in input capture, you're getting a signal here, and you're trying to measure what is this, and what is this. So you're measuring your period or your width, and you can call it delay 1, delay 2, whatever you want to call it, you can call it, okay? That is going to be input capture. Output compare, you want to generate a signal like this. Okay? So in this case, what you're trying to do is, you're going to generate, so this is, we are going to measure the falling edge or rising edge, you're going to measure. Here, you're going to initiate 0 or 5, or you're going to make it high or low. Okay? So here, you're generating this signal, not measuring those signals. Are you guys clear on those two first? Okay, if I say oscilloscope, which oscilloscope I'm going to use? You're going to say input capture, output compare. What are you going to do with oscilloscope? If I give you oscilloscope for measurement something. Output compare, right? Yeah. Oscilloscope is a tool you're going to see what's happening. So you can generate a signal and measure. Function generator, you're going to use it for? So you generate some signal using function generator, you're going to measure them using your microprocessor. Clear, guys? Okay. So this two is clear? Okay. So what you're going to have, both of them have something called status register. Like this status register we have. And for this we have 3 pins, right? And here we have 5 pins. And both of them use port A. Okay? So at the time they're going to use only 1 pin. So you're going to be 3 pins for IC input capture, and you're going to have 5 pins for output compare. And at a time you're using just 1 pin. Okay? So both of them have a status register. What the status register is for input capture, it's going to look for rising edge or falling edge. Okay? So depending on what you're rising, if it detects your rising or falling edge, the corresponding bit is going to become 1. If it detects an edge, that is going to be a state register. Okay? For the case of output compare, the state register becomes 1. Okay, this is a different tool. You have this TCNT register and you have your data register. Okay, this data register, okay, for every pin you're going to have a separate register. So you're going to have 3 data register for input compare, and you are going to have 5 data register for output capture. Okay, for input compare, sorry, input capture. Sorry. Okay, input capture. What's going to happen is, so whenever you detect a falling edge or rising edge, the value in this what you call timer is going to be transferred to your data register. Am I right to say that? Okay. But when you're going to use for output compare, this value doesn't go and replace this at all. What he's going to do is, he's going to compare this and this. He doesn't replace anything, because that's why it's called output compare. Input capture and output compare. He's going to compare. He's going to compare this TCNT with my data register. Now following, guys? Seeing what different input of, okay. So this data register, you have to input. You have to input this delay. I call it D1 or this is D2. You have to input this delay inside here. But you cannot just input the delay like this here, because it won't have any meaning to it. So what you have to do is, you have to take the value of this TNC counter, which is can be from 0, 0, 0 to F. Any value, the current value, add it to your delay one and store it in your data register. Are you guys following now? You have to store it there. That's what is called output compare. Okay? Okay. Now for output compare, if the value of TCNT register, that is your clock, becomes equivalent to your data register, the value is stored in data register, now it will go and look for your control register. Do you want it to make it high or you want to make it low? Okay, because you are going to tell it, okay, now you reach this value here, now you make it high. After making it, it's going to stay high for till you make it low, right? Just keep going on and on. Now, you're going to add this delay 2 to the previous value there. So now you have a new value. So now everything is going to function, value is going to go till this new value becomes equivalent to your TCNT register. And then now you're going to tell them, okay, now you have high, now you're going to become low. Okay? Similarly, that's how you're going to choose. You're going to high or low or high or low. You're going to see. That's why it's called output compare and initially input capture. Input capture, the value in your TCNT register got automatically being transferred to your data register, input capture data register. For output compare, we are not transferring anything. We are comparing this guy with the value you have, stored in your data register. Now it's clear, input capture, output compare? Okay. Okay? Now we go back to your program. Okay, now you're seeing